Let's go to problem number 8. Okay, so the problem says here we have a regular hexagon. Regular means all those 6 angles are the same and all 6 sides, they have the same length. All right, so the question is, what is this angle AED? So first let's recall a basic fact about hexagon. So let's recall. So say I have a hexagon, regardless whether it's regular or not. Okay, so then we know the total number of angles. So this is 1, 2, 3, 4, 5, 6, right? Okay, so maybe I put this is 1, 2, 3, 4, 5, 6. Okay. So because the hexagon can be separated into 4 triangles, and we know each triangle, the total number of the sum of angles is 180. So for hexagon, I have angle 1, angle 2, plus angle 3, plus angle 4, plus angle 5, plus angle 6. So this is sum of all the 6 angles. Okay, so this equals 6 minus 2, which is 4, and times 180. So that's 720, right? So the point is, if you have hexagon, regardless it's a specific shape, the sum of all the angles is always 720. Right, so if it's regular, so which means this implies if it's regular, according to the definition, all angles are the same. All angles are the same, and so that implies each angle is 720 divided by 6 is 120, right? All right, so for regular hexagon, we get each angle is it's 120. So let's put it here. So we have this one is 120. And because these 2 sides are the same, it's isosceles triangle. So these 2 angles are also the same. So you split, we get this one is 30, this one is 30. The total is 180, all right? And then because this is also 120. So we get, from here we derive this one is 90, right? So it's 120 minus 30 is 90. Okay, so the answer is 90. So here the key point we use is number 1, the sum of 6 angles of hexagon is 720. And then if it's a regular hexagon, each angle equals 120, right? And then we'll quickly figure out this angle is 90 degree. All right, okay. Now let's do problem number 9. This is a question about fractions. So here we have 3 fractions. Obviously, they are all greater than 1, right? So those we call so-called improper fractions because the denominator is bigger than, the numerator is bigger than the denominator. All right, so now we figure out like which one is the order of these 4 fractions, right? From the least to the largest. Okay, so the most convenient way to solve this for this specific one is let's transfer this fraction into mixed numbers. That means we're going to write each fraction into the integer part and proper fraction part, right? So we are going to write as mixed numbers. So first look at the 1. So that's 53, 25, right? So this one, okay, we know this can be write as this is 50 over 25 and plus 3 over 25, right? Okay, so this is just 2 plus 3, 25. Or if you write as a mixed number, it's 2, 3, 25. All right, now let's look at 2. 2 is similar. So if it's 19 over 6 over 8, right? So, okay, so this equals to 16 over 8 plus 3 over 8. Well, this is 2 plus 3 over 8. So 2, 3 over 8, okay? And number 3, so this is 25 over 11, right? So this we can write 22 over 11 plus 3 over 11. Okay, so it's 2 plus 3 over 11. So it's 2, 3 over 11. All right, now if you want to compare this 3, obviously the integer part is the same. And then if you compare the fraction part, the other part, well, this is the same. So 3, 3, 3. And now you just need to compare the denominator, right? So this is 5, this is 6. So obviously we get this one is the smallest. This one is smallest. And this one is the largest. Okay, so this guy is in the middle, right? This guy is in the middle. Okay, so now then the order will be the smallest is the one less than the middle and less than the largest. Okay? So here the point is, if you just look at the fractions, they're given in the first place, it's not so clear which one is bigger and which one is smaller. But if we write into mixed numbers, well, or we say if we separate into integer part and the proper fraction part, okay, we can quickly figure out which one is larger. All right. All right, so now let's look at problem number 10. Problem number 10, we are looking for two-digit numbers. If we switch, it's a tenth and ones digit, the difference is 18. So we are looking for two-digit numbers A, B. If you switch the two-digit, you get the difference is 18, right? The difference is 18. So this is what we need to figure out. All right, so obviously the A shall be bigger than B. And then here we have the digit B minus A. So B minus A, the unit digit of the difference, the unit digit has to be 8, right? Okay, so then of course the B cannot be 0, right? B has to be, because we want after switch is still a two-digit number, it cannot be 0. So we want this one to be bigger than 0. So if I start from B is 1, then in order to get unit digit A, so 1 is, if you add 1 to 11, so that's minus, so this A could be 3. If it's 2, then this one could be 4, and all the way to 7, then this one could be 9, right? All right, so then we have 7 choices, right? Okay, so we have 7 choices, right? So if I write them out, so what we have is 31 minus 13, 18, right? So I have 42 minus 24, this is 18, and then all the way to 97 minus 79, this is 18, right? So we have 7 valid two-digit numbers. All right. Okay, let's look at problem number 11. The problem number 11 is Malcolm. He wants to guess the house number of Isabella. Now Isabella gives him some information. It says a two-digit number, right? So okay, so it's two-digit number. It's two-digit number. Okay. Now also, so here it's from 1, 2, 3, 4 pieces of information. The first one says it's prime, the second says even, and divisible by 7, and one of them is 9. And also says exactly 3 of the following statements are true. That means one and only one, exact one is false, right? So we have exactly one is false. All right. Now, so what we need to do is we need to figure out which one. So we need to figure out which one. So this we need to do. All right, so let's look at the first statement. The first statement says it's a prime. And the second statement says even. Okay, we know the only number that could be both, like let's say for these two statements, if both of them are true, that means this number is both even and prime. And we know there's only one even prime number, that's 2. Right? But it has two-digit number, so it's impossible. So which means 1 and 2 cannot be both be true. So we get, first of all, we get a 1 and a 2 cannot be both true, which means one of them has to be false, right? And also it says 1 is prime and the third says divisible by 7. Okay, so a number is prime. Let's say 1 and 3 are both correct. That means a number is prime and divisible by 7. Well, there's only one such number, which is 7 itself, right? Otherwise, it cannot be prime. Okay, but again, it has 2 digits. So which means 1 and 3, they cannot coexist. That means one of them must be false, right? So we get, okay, so we get 1 and 7 cannot be both true. And then we combine, because there's exactly one false, we conclude, so this conclude, since there's exactly one false, and this conclude, 1 is false, right? 1 is false. Because if 1 is true, then both 2 and 3 are false. And this is not what we want. What we want is exactly 1 is false among the false statement. All right, so we get a 1 is false, so we can get rid of this. And then we say, okay, so it's even, it's divisible by 7, one of the digits is 9. If one, okay, so this, remember, they're all true. So this is true, this is true, this is true. Okay, good. Now, one of its digits is 9, but 9 cannot be on the unit digit because it's even, right? So the 9 has to be here. So we get 9 has to be here. 9 cannot, as I said, 9 cannot be on the unit digit because it's even, right? All right. So then again, it also has to be even. The unit digit has to be even. So this one has to be even, right? So this one has to be even. Okay. And also it has to be divisible by 7, right? Plus this divisible by 7. You 9 with an even number divisible by 7. I was okay. So the only option is, so we from here all this information together, we get the only valid number is 98. Okay. So 98, so 98 is divisible by 7 because 98 is 7 times 14. It's divisible by 7. All right. Okay, so the one of the digits is 9 and it's even. So it's 98. So what's the unit digit? So unit digit is 8, right? So 8 is the unit digit. So it's 8. Okay. All right. Now let's look at problem 12. So this is a number puzzle. We have the three-digit number together, and we just need to figure out so those numbers which are not explicitly given, right? So 4 of them. Okay, so let's start from the unit digit. So 3 plus 2 plus q, so 5 plus q. In order for the unit digit to be a 2, so we from here we get the q must to be the q has to be 7, right? It has to be 7. All right. Maybe let me write it bigger. So it's n. Oh. So it's n 6 3 7 p 2 5 8 q. They add together is n 0 4 2. Right. Okay. So this one is q. All right. So as we just said, this guy has to be 7, right? In order to come up with 2. So if this is 7, 5 plus 7, so 5 plus 7 is 12. So one carry over is 1 here. All right, so we have 6 plus 8 plus 1 plus p. So if you look at this vertical line, all right, so this one equals 15 plus p. It has the unit digit has to be 4, right? In order to get the unit digit 4, so we get the p has to be 9. All right, so we get the p is 9. So this guy is 9. So 9, so then 9 plus 15 is 24. All right, so I have carry over is 2 here. All right, so then we need n. So if you look, I look at this. Okay, so it's n plus 7 plus 5 plus this carry over 2. So this one we need to end up with unit digit, which is 0, right? So it's 0. Okay. So what's this? So this is n plus 14. Well, in order to come up with unit digit 0, it has to be 20, right? So that means n is 6. So we got this one is 6, right? Okay. So then it's 20. So it's will be 2 carry over. So this one is 2. Okay. So now we get. Let me summarize this. So I get n equals 2. N this is 6, and the p is 9, and the q is 7, right? Okay. So if you add together, so it's okay. So we just need to find the sum of these numbers. So it's 11 plus 13, which is 24, right? So it's 24. Okay. Right, so let's look at the number 13. So number 13 here, we have an equation. So this equation involves two variables, which are x and y, and also squares. Usually for this kind of equations, it's quite hard to solve. But here it's kind of special. It says x plus 1 squared plus y minus 1 squared equals 0. The right hand is 0. Now this special, why is that? Because for any square, so if I have any square, a to the square, this one is always non-negative, right? Because you think of if a is positive, say a is 1, so 1 squared, which is 1, which is positive. They say, oh, we have a negative. If a is -1, then -1 squared, this is also 1, is positive. So the point is the only A to make this A squared is 0 is A has to be 0 itself. So when we look at this, we say, okay, because this one is always non-negative, this is always non-negative. Now, in order to get 0, we have to be this 0. So we implies x plus 1 this square, this guy has to be 0. And we also get y minus 5, this one also has to be 0, right? So that's the key point. So let me repeat. So the point is, if you have a square of something, right? If this guy is not 0, it's always positive, right? It's always positive, right? If you have positive number squared, positive, negative number squared, it's also negative, right? It's also positive. Okay, so if you add them together, you want to be 0. Both of them have to be 0. Right? For square to be 0, that one it has to be this A has to be 0. All right. So from here, I say, okay, so I get this x1, this one has to be 0. I get this one has to be 0. So I get x plus 1 is 0 and y minus 5 is 0, right? Okay. And this implies that x is negative 1 and, this is 0. So y is 5. So we have the x plus y is 4. Right? We get xy plus y is 4. Now let's look at problem number 14. So this is a problem about a probability that says Abel tosses 2 coins and Ben tosses 1 coin. So what is the probability that they get the equal number of heads, right? All right, so now let's recall. So the basic formula for probability is a fraction. Typically, it's a fraction. So it's the denominator is the number of all cases, and the numerator is the number of valid cases, right? Okay. All right. So here, of course, the valid cases is those situations where they have the same number of heads. Now, first, let's figure out the number of all cases. So here we have Abel, and this is Ben. So Abel tosses 2 coins. So each one could be head, tail, and Ben tosses 1 coin, so head, tail. All right, so Abel has 4 scenarios, right? If it's 2 coins, head, tail, okay, so by multiplication principle, it's 2 times 2 is 4 scenario. You can write it out, so it's like head, tail, right? Head, or it's tail, head, and tail, right? Okay, so Ben has only 2 scenarios, it's just head or tail. Okay, so then we get the total number. So this implies the total number of cases is, now we apply the multiplication principle, is 4 times 2, which is 8, right? Which is 8. Because Abel has 4 choices, has 4 situations, and Ben has 2 situations. If you combine together with multiplication principle, right? Okay. Now, so we calculate the valid cases. So let's list out all those valid cases. One is both of them have 1 head, right? Okay, so for this we have its head, tail, head. Okay, so this is Abel, and this is Ben. Or we have tail, head, and head, right? Okay, so if that's the case, that Abel has 1 head and Ben also has 1 head. Right, so that's another case, because here we said equal number of heads. This also includes the situation both of them have 0 heads, right? So which means they all get tail. So both of them have 0 head. Okay. So then we have the situations Abel, this is Ben. We have its tail, and Ben is also tail. Okay, so it has only 1 possibility, right? It has 1 situation. So this is 2 situations, and here's 1 situation. So if you add together, the number of we get implies the number of valid cases is 3. Right? Is 3. Okay, so now we apply the formula. So we put this one to the numerator, and we put the total number of cases to the denominator. Okay, so this gives us a 3/8. Right? So this is the probability. It's a fraction. All right.